Hey, it's Mr. N going over the Precalculus Chapter 1 Test 1116 taken September 26, 2019. This is versions G and E. Question number 1. Write a function that represents a parent function y equals x squared has been translated 2 units down. So 2 units down, this is going to be a negative 2 on the k value. And then it says 3 units to the right. And to the right means that your h value is just going to be 3. So y equals like 1 to the x minus 3 squared minus 2. And that would be this one right here. Remember my silly phrase, add to x, go west or left. Add to y, go high. What does that mean? The adding to x, if this was a plus x, you would actually go to the west or left, but this is saying to the right. So in some ways inside it's the opposite, and then the outside, if you're adding, oh, it says translated down 2 units. I might have to let you guys take that question over again. Change out to a minus sign. Because that has to be a minus. If we picked minus, that would go to the left. Down 2 units. That's only minus 2. Alright, I need to tell you guys that choice is different. Okay, we'll make that correction soon. Question number 2, multiple choice. Evaluate the piecewise function. Here's function notation. If you put f of x above it, it tells you x equals negative 5. Now, I just put a graph over here if you wanted to graph it, but essentially what you take is x equals negative 5, and then you're basically going to pick one of these. If you put negative 5 here, negative 5 is bigger than negative 5, that's false. Negative 5 is smaller than or equal to negative 5. That's true, so you would put in negative 5 into the second one. You would get the opposite of negative 3, which is positive 3, so that would be choice number 3. Question number 3. Use a graph to write the name of the basic function in the first blank, and then the equation function in the second blank. So the name of this is starting here at 0, and here it's going to end at 0. This is called the sine function. The sine function starts at 0, ends at 0, and the equation is y equals sine of x. As some of you guys are asking how to graph either of these, let's put those in, show you guys. Zoom out so you can see the calculator commands. Alright, for the table of values here, I'm just going to do in parentheses x plus 2 divided by parentheses x, and then to get the inequalities it'll be test, so second test, and then it's under test, so that would be greater than negative 5, and then negative x plus 2 divided by x test less than or equal to negative 5. Zoom 6. Here's your graph. It's a piecewise function. So there in red you have the second one, and then blue is this first one because you know it has a positive slope. And you're asking what's happening at negative 5. Well, you're not quite sure, right? Here at negative, this one should be a closed circle, that one's an open circle, so you would do the closed circle. And another way of verifying that is just pressing second table, and it's kind of telling you what to do. So at negative 5, and if you put in negative 5, you'll see that it's an error on the blue one, but the answer is 3. So that's another way of using your calculator. For this question number 3, if I clear all this out, the sine function, y equals sine of x, so it's sine, and then x. But normally you would press zoom 6, but this one you have to press zoom and then number 7 trig, because what it's doing there at number 7 is you're graphing trig functions, and so here you have radians, so it completes its period by 6.28 radians. So before with zoom 6 it's by units, this one's by radians. That's how you get the accurate graph. Question number 4. Graph the following function, f of x equals x squared 5 minus x. So I'm just going to put that into my calculator. X 5 minus x. And then what I'm going to do is just press zoom 6. Okay, I got a graph here. I'm going to trim up the x values, so I'm going to go up to x minimum of maybe about -3, and I need to go higher on the y values. So I'm going to go to window, -3, and the y, and I'm just going to guess 50. Y scale just basically means those little tick marks on the y-axis. How much do you want? Let's do 10. Okay, that gives us enough, so let me go ahead. Looks like it's going through the origin. And then what I'm going to do is I'm going to use the calculator to identify the local minimum, local min, and then the local max here. And again, why they are local, not absolutes, is because this mountain goes higher, so there's a higher maximum or absolute max, and the mountain goes lower, so there's a lower point. So the calculator commands I'm going to use, I'm just going to go to calculate, so second trace. Let's calculate the minimum. Should have maximum points right there. So minimum, we're going to go left bound to the left, press enter. I'm going to go to the right of it, anywhere to the right of the what I think the local minimum is, and exactly on my guess. And this one's a little bit tricky. This one's actually telling you all of these numbers. Now, E is scientific notation, and then E means a negative number. So essentially what it means is moving that decimal place 8 places to the left. What it's essentially telling you is this is 0. I'll show you guys another way of figuring that out algebraically, but let's do the maximum. So I'm already to the left of it. You can actually just press enter. And you can go all the way to the right, press right. And then my guess. Basically what the computer is doing is looking for the highest y value in that interval. So 3.33 to about 18.52. How would you do that algebraically? This is a multiplicity problem. You can just set each of those equal to 0, x squared equal to 0, and solve. You get x equals 0 is an x-intercept. Because it has an even, we call it a bounce or a kiss. And then this is to the power of 1. It's going to be shooting through the x-axis. So you just do 5 minus x equals 0. Negative x equals subtracting by 5, and then you get x equals 5. So that would be that point. You don't need that one. But this one, we kind of suspected that it was going to touch at the origin. Where is the graph increasing? So increasing is basically from here to here. Now, the increasing in interval notation, identify the intervals on which the function is increasing, decreasing, or constant. Use the above graph or the graph over here to answer the questions. So remember, you're going from left to right, and the interval notation that I'm going to write are actually the x values. The x values. Okay? Because it's already implying the increasing, the numbers are getting bigger on the y values. That's implied by the word increasing. So I'm going from here. And we stated that here in the roller coaster, as you go left to right, right here is not the exact point is not increasing nor decreasing, so that's why I use a parentheses at 0 up to this x value, which is 3.333. Whereas a graph decreasing, the roller coaster goes down at these points. So in pink there, from negative infinity to 0, again you're looking at the x values, union with 3.33 to, remember this is not negative infinity, that's just saying the values are going to keep going on the x's, so lots of big numbers on the x's, that's positive infinity. Where's the graph constant? That was meant to be, the question is if it was, a flat line here, interval notation. So you could say something like at x equals 0 and at x equals 3.33. I would also accept if you just said there were none. Again, I was looking if it was a horizontal line. Is it continuous? The answer is yes, because you don't ever pick up your pen to finish that problem. Question number 5, which function is bounded both above and below? So if you just draw yourself some graphs, and hopefully you memorize that. A, B, C, D, E. Let's get some different colors in here. Hopefully you memorize these. At A is a quadratic, and you can graph these in your calculator. Shifted down 4 units. So that's what my graph looks like. You have a cubic function shifted to the right. Might look something like this. There you have a exponential. So go ahead and punch those in. You can actually see the graphs. Just to double check, x squared minus 4, zoom 6. There's my graph. X minus 3 to the power of 3. So you can do that button by using the caret button, which is over here, and then 3. And then you have 3e to the x power, so 3, and then your e button is here in blue next to the 4. So I'm going to have to use second natural log x. Graph that. And then here you have a logistics, so you do 3 plus. And there's 2 ways of doing the fractions. You can do alpha y equals. That's one way of getting a fraction. You just type it in. Or you can do, old schools just use parentheses. 1 plus. So that the 1 is in the numerator. Sorry, parentheses. Nope, that's the divided sign. I'm going to use an extra set of parentheses. Yeah, let's go back to the fraction. So I have 1 over, and just press down or left or right to get out of there. 1 plus e to the negative x. You can graph that. Again, that's just a logistics shifted up 3 units because of the plus 3. So it's going to look something like this one. And then e is the absolute value. Again, you should recognize that the parent function is, and then just a bunch of things are happening. A value is negative, so it's going to be flipped, and then plus 4, your constant is going to be shifted up 4 units. So 4 minus, if you go under math, which is right here next to apps, go over to number, and then the abs is your absolute value function. And I think you can also get the absolute value by going to alpha F3. No, alpha F2. Right there in abs. So here's my graph, zoom 6. There's my graph. Okay, so you have these graphs, and you should have recognized this again by the parent function. So this one is bounded below only. Bounded below only. This one is unbounded, because it's not bounded above, not bounded below. This one looks like it's bounded below only. So unbounded means it's unbounded both above and below. You can go anywhere in the school, right? This one has boundaries below, and above, so this one is bounded. This one is only bounded above only. So the only one that's bounded is D, the logistics. Let's count up how many points we got. Alright, I got 2 points, 1 point for your name and period, 2 points for the multiple choice, which I need to figure. Let's see. We have to change it 3 units to the right. Once we change it 2 units to the right, and then 3 has been translated 3 units. So be up. Then that would be choice B. 2 units to the right, and then up 3 units. So that would be 2 points, 2, 2. I said 1 point for the graph here, and 1 point for all of these. So 1, 2, 3, 4, 5. 5 points here. And multiple choice 2. So 1, 2, 3, 4, 5. 5 times 2 is 10. You have 15 points for that side. That works. Turn to the back side. Make sure to show all your work and box your answers. Given f of x equals x minus 3. So what I'm going to do is I'm just going to find their domain right away. And this tells me negative infinity to positive infinity, right? Going from left to right. The arrow says I can go from negative numbers to positive numbers. And then x squared plus 9 is just a quadratic shifted up 9 units. And so, again, I don't know why I drew that line, but anytime you have 2 arrows, it's essentially negative infinity to positive infinity. For your domain, you can pick any of these values. Okay, so when I add these, f plus g, so I just have x minus 3 plus x squared plus 9. And then from there, I'm just going to drop the parentheses because I don't need them. And then at the same time, I can also combine like terms. So there I'm going to have x squared plus x, and negative 3 plus 9 is plus 6. And then it says find the following below along with their domain. So if I look at which one's the most restrictive, the answer is it's the same. So negative infinity to positive infinity. Parentheses, and then this would be my answer. I have to look up at last year's test, but I believe I made the domain 1 point and then your answer 3 points for this one. 6b says f minus g, so x minus 3 minus the g function, which is x squared plus 9. Now, the parentheses are important for the minus sign because now I got to distribute this negative 1. So this would give me x minus 3 negative x squared negative 9. Now I can just combine like terms there, write in descending order, negative x squared plus x minus 12, and then the most restrictive domain is telling us that basically you can pick any, even though you're combining the functions, you can pick any number. Alright, question number 6 says f times g. F times g, so that would be x minus 3 times x squared plus 9. Okay, there's a couple of ways you can do this problem here. You could use FOIL. I'm going to use a box. So I have x minus 3, and then I have x squared plus 9. We're going to multiply first. X times x squared is x cubed. X times 9 is 9x. Negative 3 times x squared is negative 3x, and negative 27. So then if I look here, I'm going to combine like terms, but none of these are like terms, so I'm just going to have equals x cubed minus 3x squared plus 9x minus 27. And that has a domain of negative infinity to positive infinity. So be careful. If you just wrote them down, I probably would have given you 2 points. If you got them correctly, 3, and then with the domain, 4 points. 6D is probably the more difficult one because you have division, and this is the rational function. So x minus 3, that's f, over x squared plus 9. Now you can't simplify that because you remember x, you can't cancel the x's because you have add-ins. They're not factors. They're not in parentheses and you can't break them up. The second thing you want to do is look at the domain of a rational function algebraically. What does that mean? You set the denominator not equal to 0. And you solve. So we subtract 9. And then you take the square root, so you have x equals plus or minus, the square root of negative 9 is negative 1 times 9. You're going to get x equals plus or minus, square root of 9 is 3, so the 9 can come out. And the square root of negative 1 is I. Okay, what does this mean? This means that our solutions are complex, so there are no restrictions in the x's, in the reals, so you can actually pick all of them. The reason why that's the case, the reason why you can pick all the numbers is right there, plus 9. That means if you put in negative numbers and square them, you'll get a positive, and positive plus positive is positive numbers. Remember, if that number equals 0, that would be undefined. That's the part you're trying to exclude in the domain. So pay attention to that math operation. Okay, determine the symmetry of f of x equals x squared minus 1. So there is, maybe in the previous test I wrote here inverse. Okay, what does the inverse mean? Inverse means if it is a function, vertical line test, then you do the horizontal line test, and then you would switch them, right? That was the separate idea. Let's put it in a separate color. But that is not symmetry. Symmetry is looking at a graph and to see if it is symmetrical, right? I can look at this graph up here and see if it's symmetrical. I can look at this graph here and I can see if it's symmetrical about the y-axis, the origin, or if it's none above. Algebraically, what do? Well, all you have to do is sub x for sub negative x for every x value. So f of negative x equals negative x squared minus 1. Negative x times negative x is a positive x squared minus 1. And every time you see f of x, you can write x squared minus 1, or if you see x squared minus 1, you can write f of x. So I see x squared minus 1. Instead of writing that, I'm going to write f of x. What does this mean? When I substituted negative x for every x, I get the original problem. That means it is even. Symmetry, because taking the opposite, or sub negative x for x, results in the original. I mean, if you just showed me that, I'd be super happy. What happens graphically? Well, if you graph this, put in your calculator, you're going to get a quadratic shifted down 1 unit. There it is. And remember my phrase, evenly. And why my silly phrase works that way? Because the L in evenly is where it is being symmetrical, right? This is where the mirror is showing the other side. Kind of hard, but you get the idea. So we can say it is symmetrical about the y-axis. Okay? Alright, question number 9. Question number 9. Trying to find the extra credit questions, or what I chose. Find the x and y intercepts of the following. So to find a x-intercept, you're going to make y equals 0. Where's the y? Right here. So I'm going to have y equals sorry, I'm looking for the extra credit answers. Y equals negative 2x over x minus 6. And then every y value makes 0. Negative 2x over x minus 6. And to make this a fraction, I'm going to put it over 1. You can do something called cross-multiplying. It really just saves you a step of algebraic steps. So 1 times negative 2x is negative 2x. 0 times anything is 0. Divided by negative 2. X is equal to 0. So when the y value is equal to 0, the x value is equal to 0. So this is my x-intercept. Let's find the y-intercept. The y-intercept, you're going to make x equal to 0. And if you ever forget that, like I always forgot all the time, just think about it conceptually. If you just draw yourself a graph and say, oh, this is an x-intercept. What is the order pair? You make up some numbers. 2, 0, right? X, y. That means the y value is 0. Or if you come over here, do something like this, 0, 5, I make up an order pair based on that. My x value must be 0, and my y value is some kind of number. Okay? So if we make x equal to 0, I'm going to get negative 2 times 0 is 0, and 0 minus 6 is negative 6, and 0 divided by negative 6 is 0. So this graph is kind of weird because it is going through the origin twice. Okay? I'll probably just be using the same scale. If you got one of those with a lot of work towards the other one, that'd be 3 points. Of course, you got both of them correct, 4. 2 points, maybe we got 1 correct, and then 1 not even close, and then 1 for just trying. Something like that. Okay. It says make sure to include your asymptotes. So vertical asymptotes. You're going to set the denominator not equal to 0. So x cannot equal 6. Then purple. Okay, my horizontal asymptotes. You're going to compare the top and the bottom, right? So the top has the highest degree of 1, so I like to write top 1. Bottom, its highest degree there is also a 1. So when they are equal, you will reduce. What does it mean to reduce? You will have negative 2x. You're looking at their highest degrees with the coefficient in front, and this is 1x. So if you reduce there, you're essentially canceling your x's, and you get y equals negative 2 is my horizontal asymptote. And then a table of values. So if you need a table of values, one of these colors is your hint. And the hint is 6. Let's draw this graph. So I gave you a table of values. Before I make the table of values, I just want to show you visually what's happening. So let's go ahead and graph this. I tried to give you guys nice graph paper, it didn't work. So just put it in there. And I'm going to guess that 4 of these. Something like this. Again, apologize for not having graph paper on there. That one's way off, but you get the idea. Okay. X cannot equal 6. There's my vertical asymptote in purple. So let me go ahead and draw that one in purple. 1, 2, 3, 4, 5, 6. And I like to draw a dashed vertical line. And remember, it's actually not a vertical line. It's just where the graph cannot go. And if you put in your calculator, it's going to be error. So what does this mean? So with this problem with only one vertical asymptote, that means there's going to be 2 parts of my graph. 2 parts of the graph. And if you think about it, this is where 6 is. So I need numbers that are smaller than 6 and bigger than 6. Imagine that purple line, and you can just kind of need numbers smaller than 6 and bigger than 6. Why did I draw it at positive 6? I mean negative 6. Try that again. 2, 3, 4, 5, 6. So I should have one way over there. Alright. There we go. There we go. We're on the right page now. So, no. So numbers that are smaller, 5, 4, 3. And then numbers that are bigger, 7, 8, and 9. Punch that into your calculator. There it is. Alpha, y equals, or you can just use 2 sets of parentheses, negative 2x. So you can delete that one. X minus 6. So 6. You can already see what the graph's going to look like. Approaching the asymptote. I did not want to show you the graph beforehand, but I meant to show you the table. So second table, let's just say it's not punching out numbers like you wanted to, so that doesn't make me happy. So what I'm going to do is I'm going to go to second window to get the table set, and I want to do auto. Let's make sure there's nothing that equals. Okay, so second table, and then now it's doing those automatically for you. Mine are becoming fractions. Press plus for table change of what? I don't know. That work? I'm not quite sure how to take off my fractions. Let's try this calculator. Old school. Negative 2x divided by x minus 6. Table set, the auto, second table. Okay, here we go. There's some numbers. That makes us happy. Okay, let's go to 3. So 0, 0, we already know that's the intercept. So I wrote down 3, I get 2, 4, 4, 5, 10, 6, error or undefined. 7 is negative 14, 8 is negative 8, and then 9 is negative 6. So if I graph this order pairs, 3, 2, 4, 4, 5, 10. Okay, so it's okay if it goes like way off the page. 4, 5. Let's just say it's something way up here. Then I know the graph's doing something like that, right? 7, negative 14. So this is 7 way down there. But I want you to notice what's happening to the numbers. They are getting closer. 1, 2, 3, 4, 5, 6, 7, 8, something like that. And then 9, maybe over here, 6. 1, 2, 3, 4, 5, 6. Okay, so I should have changed mine, but let's go ahead and put all the clues together. So I have the y-intercept from above, 0, 0. I have the x-intercept here. And then I have a horizontal asymptote. Now, I think we talked about the horizontal asymptote. Sometimes the graph actually crosses it. It can never cross a vertical. And so this might give you a hint that, remember that purple line shouldn't be there, that there's kind of like 4 quadrants to the graph. 1, 2, 3, 4. And so if I ever ran out of space, I know the graph has to be in 2 of those places, and the table of values kind of tells us where. So let's go back with a nice colored pencil or something. And my graph is probably going to look something like this. So I definitely need to have 2 parts of that graph. Alright, so we've been working on graphing rational functions. Let's just count our points. These were 16, 16, 20, 24, 24. Can I not count? 4, 8, 24, 24, 26. Can't count. So the test was out of 41. Credit question. I believe, what year did Savannah High School open? The answer is 1961. And the other question is, who is our main rival? The answer is Magnolia. So if you got that right exactly, then it'll be 2 points. Hope that was helpful for your test corrections.